All right, in this video, I'm going to be looking at WizardLM. So this is a new academic paper that also includes a model, which most people are just talking about the model, and also includes a data set as well. And the thing I'm going to say actually is that for me, the model itself is probably not the most interesting thing about this project. So this comes out of Microsoft. I think it's from Microsoft Research Asia. I'm not 100% sure about that, but I think so. What they've basically done here is a really interesting idea, building on where alpaca was going. So if you think of alpaca started out with 175 written human examples and then distilled from GPT-3 that amount up to 52,000. And it turned out that in that data set, there were lots of errors. There were quite a number of bad responses, that kind of thing. And that's why people went through manually and looked at it and created the cleaned alpaca data set. So one of the things, and then this also led to people basically training more of these models on distilled data sets. So a distilled data set, if you're not familiar with the term, is something that's basically been taken from another large language model and is not something that's been created by humans. Usually people are using OpenAI. Usually people are using either the GPT-3 model or the ChatGPT model. I think we're starting to see some people look at using the GPT-4 model for this. Now, there's a whole controversy around whether that is legal to do or when is that legal to do. There are, moral issues of where some people say that, okay, they scraped the internet, so of course, whatever they've got, it's hard to defend legally. I don't want to get involved in that. What I want to look at in this particular thing is this idea of how do we distill a better data set than actually what came from alpaca? And then if we distill a better data set, how does that relate to actually training up a model that's going to be better as well? So if you're just here for the model, look at the bottom. You can skip along to the Colab and I'll walk you through the model and stuff in a bit. The idea with the paper is really interesting. So they've released a data set and they've released a model. And this current model and data set is a 7 billion parameter model trained with a 70,000 examples from what they're calling evolved instructions. The cool thing that they're working on is that they're working on another version of this, which has 300,000 instructions. So my guess is pretty soon we will see either a better WizardLM2, 7 billion, or perhaps even a 13 billion or bigger model. So let's look at the paper and look at what this actually does. With the alpaca idea, they took a human written instruction and then spun variations out on that. Here, what they're doing is that they're basically taking a core data set, similar kind of idea, but then what they do is they evolve these instructions. So they start out with a very simple kind of instruction. And this is one of the key things that they point out about things like ShareGPT and Alpaca, is that the instructions on the whole are very simple instructions. And because you're just training and fine-tuning on simple instructions, you never actually give the model enough sort of hard instructions so that it won't be able to do those when it just comes to inference time. So their goal is that you start out with some sort of simple instruction, and then they actually just use a random process through the prompt, and we'll look at the prompt in a minute, to develop this sort of simple initial instruction into something that's going to be much more complicated. And that could be going in a variety of different directions, as they're showing in this diagram here. And then when they get something that's more complicated, they will store that and keep that. But then they'll often also go, okay, let's make a more complicated version of the complicated version kind of thing. And so they raise these up through degrees of difficulty as they go along. And the idea is that they're getting both simple instructions right through to very complicated instructions. And when they do the actual fine tuning, they want to have a nice mix of these so that you're not just training on sort of 80% really simple instructions and 20% really hard instructions, that you've got simple, medium, right through up. I think they go through 10 levels of difficulty in here. And you can see that the way that they talk about this is that this idea of evolving or mutation. Now, they have checks in there to see that if it evolves in a way that doesn't make sense or something like that, they then don't accept that. They're just going for the idea of it evolving and getting to something more complicated. So if we look at their diagram here, they will basically come up with an initial instruction. They will then generate out some different instructions. I guess this is what the wizard is supposed to be doing here. And we'll see in a sec that the wizard, if this is what the wizard is doing, it's just a prompt that does this. If they find, they basically have an instruction eliminator. If they find something wrong with an instruction, they take it out. Otherwise, they pass it through and they store it into the instruction pool. So let's look at how they're actually doing this. So they talk about the primary purpose of the in-depth evolving is to make currently given instructions more complex and increase their difficulty level. And we can see if we look at this prompt. So here they talk about the prompts. They're very careful that they don't make it too complicated too quickly. So they always want to push it we limit each evolving to be a bit harder and restrict adding a maximum of 10 to 20 words. So the idea is that each instruction should be slightly harder, but not too hard. So they're getting these levels of difficulty or the degrees of difficulty as they go through. The prompt template is as follows. So they have this prompt template and then they just randomly change out some of the prompt here. So you can see the idea is that I want you to act as a prompt rewriter. Your objective is to rewrite a given prompt into a more complex version to make those famous AI systems, i.e. ChatGPT and GPT-4, a bit harder to handle. But the rewritten prompt must be reasonable and it must be understood and responded by humans. So they've got a whole sort of prompt thing going on here. And you can see these bits where for certain things, they will add a constraint or a requirement. For certain things, they'll have different ways that they can mutate it and change it. And so this is an interesting idea. So this idea of evolving and mutating things and then picking the best ones, I haven't seen it applied to prompts directly before, but it's something that's been used in machine learning in the past, that's for sure. So this is what's going on in here. And from this, they then go on to train up, and they've got all their prompts in here. It's a really nice paper, actually, for seeing what they've done and for them explaining what they've done in there. So they've got these things going on. Like I said, they've released a data set. So they've got this data set here, and you could go and train your own model on this data set already. And they're already working on 300,000, approximately 300K, which is going to be the full evolved instructions. And they're planning to train another model based on that. So that's something that's interesting to look at. All right, so they've released a demo. If you want to try this out without having to run it yourself, come in here, try this out, see how it goes for you. The model, I'll just give you the TLDR thing. The model is definitely very good. It's not perhaps as good as the stable Vicuna model that just came out, but that model is almost twice as big as this. So I wouldn't expect that this would necessarily contend with that. But you could imagine that a version of the WizardLM, so a llama model trained on 13 billion parameters on this 300K data set, is going to be pretty good and probably perhaps even better than the stable Vicuna model with the RLHF. So this is definitely a nice, interesting alternative to using RLHF for this. So I've got a Colab here. I've set it up the same as my other ones. I've put in some filtering stuff that I basically was using from the stable Vicuna in here. And we can come through and just look at the standard outputs. On the whole, I think that the standard outputs are actually very good that this model is doing. When we ask it the questions about the llamas, Vicunas, it's on top of that. It does make mistakes. And these mistakes, I think, can be attributed, a lot of them attributed to the model size, that perhaps a bigger model would do better for this. So here we can see that we've asked it about GPT-4, it's replying about GPT-3. So that's not a good sort of sign. The simple questions like, what is the capital of England? Yes, it certainly knows that. There's no problems with facts like that. Writing the stories, I feel like it's perhaps not as good as some of the other models that have come along, like Koala or something. But again, that was trained on with extra data sets that relate to stories and poems. So that sort of benefited, I think, from that. Unfortunately, I know for a lot of people are going to find that it doesn't do a good job where if you don't like that as an AI language model, it tends to say that quite a bit, what I found. So in this case, the Stable Vicuna model was doing much better in its answers, that we didn't get that as an AI language model in here. Now, this is probably because their instructions have been distilled from ChatGPT, where it says this a lot. So you could imagine that once the 300K version is out, you could filter that data set to remove all the as an AI language model responses and be able to get a better, more open data set for doing fine tuning for something like this. Okay, its logic and reasoning was not very good here. So we can see here that this is the same question that we asked it before, where you've got 23 apples, you use 20, you buy 6 more, should be 9. Unfortunately, here it's saying that it's 3. So again, this is partly due to the size of the model, I think, although it could be that they've just not fine-tuned on this. And my guess is on the evolved instructions, you're going to find that there are probably quite a number of errors in there just from the way that they've done it. I don't know that. I'm just guessing at that. But from when you're spinning up and distilling large data sets like this, later on you tend to find that, okay, actually there were mistakes in this, the alpaca data set being the classic one there. That said, this was a question that the Stable Vicuna got wrong, which was, can I write a haiku in a single tweet? And this one says, yes, you can. And it actually goes ahead and writes a haiku there. I think that's a haiku. I'm not sure the number of syllables, etc. When we ask it the hypothetical questions, it doesn't do a great job of these. Can Geoffrey Hinton have a conversation with George Washington? It really doesn't get the concept of this question. So it's answering, I can provide information and questions. However, it's not possible for me to physically bring together two individuals who are not alive. Again, this would be interesting to see, have any of these sorts of things been mixed? What's in the data set that's like that? So this kind of data set is a very academic data set. And so it would be interesting to see something like a WizardLM or a Stable Vicuna trained with some of the academic stuff as well as the more distilled sort of data sets or RLHF data sets too. They're going to do very well. If we ask it, can Geoffrey Hinton have dinner with Harry Potter? It doesn't really get this at all. It appears to be hypothetical or fan fiction type of question that is not based in reality. That's true. I guess in many ways its answer actually is accurate, but it doesn't propose a nice simple answer for this. When I ask it some facts about Marcus Aurelius, these were things I did with Stable Vicuna. It does quite a good job on this first one, asking about 3 facts. It actually gets his son, whereas Stable Vicuna got this one wrong. And it then also gets the other questions about him, right as well. So it does a good job on both of those. Final question, since it was the WizardLM, I asked it, tell me about Harry Potter and studying at Hogwarts. And we got as an AI assistant, I can provide you with information on the fictional world of Harry Potter. And then it gives us some stuff from the thing, which is actually not bad. Anyway, have a play with the model. The data set, I think, is something that's very interesting. My guess is that in the not too distant future, we're going to see a WizardLM 2, which is probably going to be better than this. And we may even see a 13 billion version of this, which is going to be a lot better than this. So stay tuned for those things. As always, if you've got questions, please put them in the comments below. If you found the video useful, please click like and subscribe. I will talk to you in the next video. Bye for now.